All right. So last class we started the quadratic function section. We said a quadratic function looks like a parabola, which is this or this. A parabola opens up if A is positive, and it opens down if A is negative. So we identified parabolas from our graph. We found the vertex of the parabola. Regardless of the form, we can still find the vertex, right? So that's what we did. And then we started talking about graphing. So here we said our shape is opening up. Our vertex is -2, -1. We found our x-intercept by setting y equals to 0. And we got 2 points. Let's find our y-intercept. And we do that by setting x equals to 0. All right. So here in my h of x equals x plus 2 squared minus 1, where is y? Y is h of x. Good. So y is h of x. So I say y equals, and I plug in x equals 0. So 0 plus 2 squared minus 1. So 2 squared is 4. 4 minus 1 is 3. So I get a 0.03. So let's plot those. Okay, so first I'm going to plot the vertex. -2, -1. It opens up, and it has these 2 points. And then I have the point over 0 up 3. So from the information I know about a parabola, what's another point on this parabola? Well, here I have my axis of symmetry. That's a vertical line that goes through my my vertex. And then this is mirrored over, so I get this point for free, right? Because it's mirrored over. So I get that point for free. If this is 2 away from my axis, then I just keep going 2 more on the other side of the axis of symmetry. And that's what my parabola looks like. Okay, good? Good. Okay, so number 2, let's do the same thing. M of x equals negative, parenthesis x plus 3, and parenthesis squared minus 4. So again, last class we talked about how we could move this around using graph transformations, but let's do the 1 through 5 up above and see how that goes instead. Okay, so 1, I'm just going to move the chart right here. So step 1 is figure out the shape. A is positive. See how these A's are the same? These A's are the same. AX squared plus BX plus C. Here I have A. If I FOILed this out, then this would be AX squared, would be my lead coefficient. So these A's are the same A's. So if A is greater than 0, it opens up. If A is less than 0, it opens down. What's my A here? -1. It's right here, right? This is my A. A is -1. That's less than 0, so that means it opens down. 2, I need to look for my vertex. Okay, so I have standard form or vertex form. I switch the sign of H, and I keep the sign of K. So switch the sign of H, keep the sign of K. Okay, so let's use our knowledge about parabolas. What do you guys think about finding x-intercepts? So x-intercepts means y equal to 0. I can set the equation equal to 0 and so yada, yada, yada. But let's use what we already know. So here's my vertex over negative 3 down negative 4 right here. And I already said it opens down. What do you guys think about x-intercepts? I don't think I'm going to have any, right? Here's my vertex and it's opening down. I don't think I'm going to have any, right? So let's make sure we're reflecting on what we have and we're thinking about what we know before we just go through the motions. All right, so let's say I'm thinking none, but let's do the math just in case we get to the test and we're not sure, right? X-intercept means y equals 0. So I'm going to take my equation and I'm going to set y equals to 0. Okay, so I'm going to add 4 to both sides. And then I'm going to divide both sides by negative 1. And now what do I do to solve? Square root both sides. What do you guys think about the square root of a negative? Can't square root a negative, right? If you do a square root of a negative in your calculator, it says error. I cannot square root a negative because something times itself is never going to be negative, right? Something times itself is positive no matter what the sign is. Positive times positive is positive. Negative times negative is positive. So no matter what, I can't get anything for this. So this is not possible. Therefore, this quadratic equation has no solution. So this quadratic equation has no solution, which means in the context of this problem, there are no x-intercepts. So no x-intercepts. Okay, so let's do y-intercept. Okay, so how do I find a y-intercept? Set x equals 0. How many y-intercepts? What are my possible number of y-intercepts? Somebody say it? 1. Why 1? So it's 1 because you're close.
The parabola doesn't go back in.
Because it's a function too, right? If it's a function, it has to pass the vertical line test, which is what you were doing with your hand, right, Josh? Yeah. So it has to pass the vertical line test because it's a function. So for every x, there's only one y. So I'm only going to ever have one y-intercept. What are my possible number of x-intercepts? 2, 0, or 1, right? How could I have one x-intercept? What would that look like? Draw some pictures if you're not sure, right? Let's draw some pictures. Okay, so it could open up, it could open down. I don't care about that, right? Here I have 2 x-intercepts, right? Let's just pretend this is my x-axis. Here I have 0 x-intercepts. It could be above or below, right? Opening up or opening down. What would it look like if it had 1? I see a couple people going sideways. Don't go sideways. A parabola is up or down. Don't go like this. Up or down. What would be that point if I had 1?
The middle of the parabola.
That would be my vertex if I had 1, right? So what would, if I had, so I could have 2 x-intercepts, I could have 0 x-intercepts, which we just saw no solution. That would be no x-intercepts. I could have 2, or I could have 1, and that would be my vertex. If that was the case, right? So again, you can open up or open down. I just drew all positive A's. But for y-intercept, I should only have 1 because it's a function. So if I set x equals to 0, I say y equals negative 0 plus 3 squared minus 4. What does that equal?
0 plus 3 squared, 5. Oh, sorry.
So 3 squared is 9. Negative 9 minus 4 is negative 9 minus 4. Negative 13, so I get a point 0, negative 13. Okay, that's not even on my graph. So here, in this case, part 5 is plot information from steps 1 through 4 and choose additional points if necessary. I'm going to say it's pretty necessary here, right? Because my other point is here, which is not even on my graph. So let's choose some more points. So I'm going to draw my axis of symmetry. What other point do you guys want to choose? You want to choose 2 points? You want to choose 1 point? What's the point you want to choose? Do you want to choose x equals 5? What?
Sure.
Morgan says no. Why not, Morgan?
Oh, I said that's fine.
Oh, you said that's fine? Okay, let's talk about the shape of the parabola again. So here I have some point over here, and I'm going down, right? If I'm saying that the x-intercept is 0, negative 13, if I choose x equals 5, my point is going to be like way down here. I'm not going to be able to plot that point either, right? If I choose an x value over here, if I can't even graph this value, I'm not going to be able to graph anything over here, right? Because it's going to be way down lower. So I want to choose something here or here, right? Okay. So what do you want to choose? X equals negative 1? Okay, let's choose that. So x equals negative 1. I plug in x equals negative 1. And I get y equals negative 1 plus 3 squared minus 4. So negative 1 plus 3 is? 2 squared is? So negative 4 minus 4 equals negative 8. So I have a point negative 1, negative 8. So over negative 1, down negative 8. So do I get another point for free? Tyler says yes. Why? So mirror it over the y-axis. So I have a distance of 2 here. I'm going to go 2 more across. So I get, from that 1 point, I actually get 2 points. Good. So I plotted my vertex, I plotted my axis of symmetry, I plotted that point I got here, but this is free. Free from symmetry. Okay. What about 3? So 3 is the other form, ax squared plus bx plus c, right? That's the only difference. Do you see how this chart above, everything's the same except for finding the vertex. So that's the only difference here. So I want you guys to do it on your own. Find the vertex, which is something we did in the previous section. So you guys try to do it on your own, right? All right, so did we find the vertex and the shape all right? So now I'm at step 3, finding the x-intercept. Okay, so I set it equal to 0. This is a quadratic equation. Somebody tell me 2 ways to solve a quadratic equation. Quadratic formula, good. Or factoring, right? So I can factor or I can do the quadratic formula. What's the quadratic formula again? Hang on a sec. What is it? So here's the quadratic formula if we ever can't factor. Now somebody remind me how to factor this. Multiply to C and add to B. Good. Multiply to C and add to B. So what are factors of 15 that add to 8? X plus 5, x plus 3 equals 0. So I set those each individually equal to 0. And I solve. So there's those 2 points. Okay, so now I need to do 4, which is the y-intercept, which means I set x equal to 0. So we get y equals 0 squared plus 8 times 0 plus 15 equals 15. So I get a point 0, 15. So that's not on there, right? Do I care? Do I need more points? I don't think I need more points. I already have 3, right? But I shouldn't be, obviously this should be symmetric, right? But I shouldn't draw where my function crosses the y-axis because that's way up higher. So that would be a mistake. But the fact that it's not symmetric, I'm not great at drawing. But I wouldn't draw it crossing the y-axis, that's for sure. All right. Let's do some fun stuff now. All right, maximization and minimization problems. So 1, a person standing close to the edge of the top of a building throws a baseball vertically upwards. The quadratic function s of t equals negative 16t squared plus 64t plus 160 models the ball's height above the ground, s of t in feet and t in seconds after it was thrown. A, after how many seconds does the ball reach its maximum height? B, what is its maximum height? C, how many seconds does it take until the ball finally hits the ground? D, find s of 0 and describe what it means. What do you guys think? Huh? It seems difficult. Okay, when things seem difficult to me, I like to draw a picture. Let's draw a picture. All right, so what is this function? Aaron says it's a quadratic, right? It's a quadratic function. What's my lead coefficient? What's my A? Negative. It's a parabola that opens down, right? Okay, I can draw that. Get ready to be impressed, y'all. Here's my building. Here's my person throwing a baseball. Here's the ball being thrown. You don't like that, Dante? What don't you like?
I like it. It's cool.
Oh, okay. Here's the building. He's impressed. I should have had Joe model the baseball throw, right? That would have been a much better picture if I would have. Okay, so a person is standing close to the edge of the top of a building. Wow, great picture. A baseball is thrown vertically upwards. So we're throwing the ball, and the quadratic function is modeling the ball's height above the ground. So I drew a parabola, right? Okay. S of t models the ball's height above the ground. So S of t is the position of the ball, right? But S of t, just like f of x, is my y values. It's my y-axis, right? So this is my S of t axis or my y-axis. And t is time in seconds after it was thrown. So usually x is my independent variable and y is my dependent variable. But here, time is independent whether I throw a ball or not, right? Time is the independent variable, so time is the x-axis. Okay, so now let's see if we can point to the place on my picture where the questions that I'm asking. So after how many seconds does the ball reach the maximum height, and what is the maximum height? So where on my picture is my maximum height? The vertex. Good. So this is the max, right? Which on the first page of this, we said if A is less than 0, we have a maximum. The vertex is the maximum. If A is greater than 0, I have a minimum, right? So that's how we're going to answer these questions. When we have maximums and minimums, we're looking at the vertex of a parabola. Okay? So A says after how many seconds does the ball reach the maximum height? So which part of my vertex am I looking at? The x value of the vertex. In this case, it would be t, right? So x value of vertex. What is the maximum height? So S of t is in feet. S of t is the position. S of t is going to give me the height of the ball, right? So this is the y value of the vertex. Good, Josie. Okay, now the question C, how many seconds does it take until the ball finally hits the ground? Where is that on my picture? Your x-intercept. Okay, I have two x-intercepts. Which one do I care about? The positive, because I don't do negative time, right? And the ball isn't being thrown to the ground, right? I don't deal with negative time usually. So this is my x-intercept. So this is positive x-intercept. Okay, and what is S of 0? The y-intercept. Good. So that's y-intercept. And describe what it means. So can somebody tell me what that means? Look at my picture, right? It's the height of the building plus the height of the person. So it's the height at which the ball is thrown, right? Cool. Now does this problem seem hard? No, and it's not because of my exceptional drawing skills. It's because we put it on the XY axis and we point it around. Because look, this problem is exactly what we just did, right? Here, it's the steps. Okay, first to draw our picture, we said, is A positive or negative? Okay, let's draw that picture. Then we said, okay, find the vertex, that's A and B. Then we said, find the x-intercept, oh, that's C. Then we said, find the y-intercept, oh, that's D. We're doing exactly what we just did, right? So let's do it now. So it's not hard, right? Not hard. So let's do it. So A, so I need the x value of my vertex. This is ax squared plus bx plus c, right? So that's negative b over 2a is the x value of my vertex. This is how I find the vertex. Okay, negative 64 over 2 times a is what? Is 2 to what? What's my units? So it's either seconds or feet, right? Those are my 2 units I have. How many seconds does it take the ball to reach the maximum height? So we're talking about time here, right? So this is seconds. All right, B says, what is the maximum height? So that should be in feet, right? We said that's the y value of the vertex. So I'm going to say that's s of negative b over 2a, which is s of 2. So I'm plugging 2 into my original equation. Negative 16 times 2 squared plus 64 times 2 plus 160. What do you guys get? What is it? 224. And what did you say the units were? Good. Feet. All right, C. How many seconds does it take until the ball finally reaches the ground? Okay, so negative 16t squared plus 64t plus 160 equals 0. All right, who wants to factor that? Just kidding. Let's do the quadratic formula. Okay, here's the quadratic formula. We know what A is. Ax squared plus bx plus c equals 0. Here's the quadratic formula. So everybody write it down. I'm going to write t instead of x. Here I have x because it's ax squared, but here it's t because it's t squared, right? T is my variable here. X was my variable there. So t equals negative b plus or minus the square root of b squared minus 4 Okay, so I get to this point, and somebody help me. What do I do? So I split it, 1 to the plus and 1 to the minus. And I need to figure out which of those is positive, right? So can anybody help me? Does anybody have a calculator? So I got negative 1.74165 and t equals 5.74165. So again, which one do I want? I don't want that negative, I want the positive. Good. So my units is seconds, right? Did I get it right? Did you guys get something different? Kehlani, did you get something different?
No, I was just asking you which one did you use to get the positive?
Oh, I use the negative, because negative minus And then over negative, negative minus something is more negative, negative over negative is positive. So that's my answer for part C. All right, D is the y-intercept. So s of 0 equals, I'm going back into my function s. Wherever I see a t, I'm putting 0, right? So it's negative 16 times 0 squared. So this one you don't need a calculator for. It's 160 feet, right? 0, 0, 160, right? And what does that represent? The height from which the ball was thrown. So it wasn't that bad, right? Once we drew the picture and we figured out what parts we're looking for, we pointed to it on the graph and we put it in terms of x-intercept, y-intercept, vertex. It was exactly what we've done. I find that some people feel like they struggle with word problems. I think if you read the problem, draw a picture, read the problem, check your picture, read the problem, write an equation, read the problem again, check your equation, then you're done with the equation. Then you're done with the word problem, and I think the word problem is what messes with people sometimes, right? I could have added in here, oh, the initial velocity was this, the wind speed was this, the baseball player was wearing a red shirt, right? You have to go through and figure out what you care about, but when it comes to it, you have a quadratic equation. You can find the maximums and minimums with quadratic equations because that's the vertex. All right, let's go to number 2. Number 2 and number 3 can be a little bit tricky, okay? Need a little stretch. You guys ready? Okay, number 2. You have 600 meters of fencing to enclose a rectangular plot of land that borders a river. If you do not need to fence the side that runs along the river, what is the maximum or largest area that can be enclosed? I do not see a quadratic equation. All right, let me draw a picture. Again, get ready. Here's my river. Here's my fence. Let's label some stuff. It's a rectangle. The opposite sides are equal. Wow. Okay. I'll add some more river to it. Okay, you have 600 meters of fencing. Can I come up with an equation for that? 600 meters of fencing is what? Where did you get that, Josie? So you're talking about the length of the fence, right? Yeah. 600 meters of fencing is the total length of the fencing. If I add up the lengths of these sides, that has to equal 600. Great. So this is total length of fence. So that's total length of fence. And Josie says if I add up the lengths of the sides, I can set that equal to 600. Good. So I have x plus y plus x equals 600. Combining like terms, I get 2x plus y equals 600. Okay. Now it says What is the maximum or largest area that can be enclosed? So somehow for area, if I'm looking for a maximum or minimum, I need to look for the vertex of a parabola, right? Oh my goodness, I don't have that. What's the formula for area though? For the area of this rectangle? Length times width. In terms of my variable, what is that? X times y. Alright, so who has an idea? So somehow I need area to be a quadratic formula so I can find the vertex, right? Can I use this somehow? So good, I can solve this equation for y and plug in here. Awesome. So if I say y equals 600 minus 2x, and I plug into here, I have area equals x. Instead of y, I'm writing this, 600 minus 2x. Okay, let's distribute that x. I have 600x minus 2x squared. Hey, look, it's a quadratic equation. And I can find the vertex of that, right? So what did we do here is we solved for one variable. Good. So we solved for one variable and plugged that back into area. Now I can find the vertex. Do I want the x value for my vertex or the y value for my vertex? What do you guys think? So the x value is going to give me the length of this side x, which is associated with the largest area. If I do a of x, which is my y value, that gives me the largest area. So I need the y value for the vertex. Okay, let me say it again because this part can be a little confusing for people. If I find the x value of my vertex, that doesn't give me the maximum area. The x value of my vertex gives me the x value associated with the maximum area. The y value, y equals f of x, or in this case, y equals the area, right? The y value gives you the maximum area. So I need the y value for my vertex. So I'm going to write a little note about that. So this is the y value of my vertex. Okay, so I'm going to do, so does that make sense? I want the y value for my vertex. A of x is the y value for my vertex. Okay, so let's do it. Vertex. So negative b over 2a equals, here this is, I need ax squared plus bx plus c, right? A is next to x squared, b is next to x, and c is the number by itself. So Joe, tell me what to write.
You would write, I don't have the,
Okay, so here's the equation that I have. B is 600 over 2 times A. A is negative 2. So what does that equal? 150 feet. So x is 150 feet, right? But the area, A of negative B over 2A, equals A of 150 equals, and then here's my a function. 600 times 150 minus 2 times 150 squared. I got that equals 4,500. Can somebody help me with units?
4,500 or 45,000?
45,000, sorry. If you guys want to check it, that's, no, I'm not trusting myself.
The unit be feet squared.
How did you get that, Parker?
Area. I just know the area is usually squared.
The area is usually squared, and if you think about it, the length of this side, the length of this side is feet times feet, so I get feet squared for area. Good. Here it said the original, oh, it should be meters, because the original question says meters. Did I say feet somewhere? Sorry. So in the question it says meters, so it should just be meters squared. But it is squared units, which is what I think you were getting at, right? Good.
Yeah, you wrote 150 feet on the vertex. That's why.
Oh, sorry. Thank you. Okay. Feeling good. What do you guys think? All right, let's do number 3. Farmer Brown has 1,400 feet of fence to build a pen for his favorite pig, horse, and cow. He needs to enclose a rectangular plot of land and separate it into 3 sections. What is the maximum area of the pen? Let's draw a picture. Okay, he has 1,400 feet of fence to build a pen that needs to be in 3 sections. So here I have 1, 2, 3 sections, right? Let's get some variables in there. Okay, again, I have 1,400 feet of fence. So let's come up with an equation for that 1,400 feet of fence. That 1,400 feet of fence, just like up above, is the total length of fence. So everybody try to write down an equation for the total length of fence. Who wants to give it a shot?
2x plus 2y. I don't know if I'm right. Equals 1,400.
So how did you get that?
It's a rectangle. So
Okay, so I have x plus y plus x plus y. What about this? What's that made of? It's still made of fence, right? Okay, so try it again. So I need x plus x plus x plus x. 1, 2, 3, 4 x's. Right? Because that's part of the length of the fence. I'm using that length of the fence to make the pens. Plus 2y. Here's the 2y. Equals 1,400. Okay, I feel good about that now. Right? So it's write an equation that you think, read it again, check your picture, check again. Right? Okay, so now it's saying what is the maximum area? Can I come up with an equation for area? Area of a rectangle, whether there's no pens, whether there's 25 pens, is still length times width. Area does not depend on the number of pens because I'm asking the area of the total, the overall pen. So this is x times y. All right, now we're doing the exact same thing as we did above. We're solving the total length of fence equation for one variable and then plugging it back in. Okay, so we have, all right, so let's do that next class. Let's do a quick quiz. Everybody draw a jack-o'-lantern. That's your quiz, do it.
Wait, really?
Yeah.